Welcome to lesson 4. We just got done with a quiz over equations, and now we're going to move into inequalities. We're going to be changing pace quite a bit here. So let's get started. The learning targets, be able to determine whether a given number is a solution to an inequality and find and show all solutions to an inequality. So we're going to start with old stuff, equations, because I want to show you the difference between equations and inequalities. So finding the solution, we would add 4 and divide by 3, I get x equals 5, right? Nothing hard there. When finding a solution, we are looking for any numbers that make the equation true. In other words, the left side of the equal sign is equal to the right side. When you plug a number in. And in most cases with equations, there's only one number that does that. So the solution to this above equation is x equals 5. It's the number that makes the left side equal to the right side, right? What about with inequalities? Well, the prefix in means not. Oops, sorry. So therefore, inequality means not equal. So we're no longer looking at what makes the left side equal to the right side. All right, so it uses 5 symbols. The first one is greater than. The second one is less than. The next one is greater than or equal to, and it has that little line under it. And you can probably guess what the fourth one is, less than or equal to. And the last one, which we won't use much of, is not equal to. A little equal sign with the line through it means not equal to. Now, a lot of people have a hard time using the correct vocabulary when they see the sign. Greater than, you see it. Less than, this is my way of teaching it. If I tilt this up a little bit, it looks like an L, which is the first letter in less than. So the one that tilts up and makes an L, a correct facing L, is the less than. All right. So continuing on with the idea here, make sure you understand this idea. If you're not going to pay attention to the rest of the video, make sure you hear this part. If a solution to an equation is any number that makes the equation true, a solution to an inequality is any number that makes the inequality true. Not equal, but true. So I need a true statement at the end. The difference is that with an equation, there is typically one solution, while with the inequalities, there are infinitely many solutions. Because there's a lot of numbers that are going to make these inequalities true. So like number 1, n is greater than or equal to 9. There are a lot of numbers, an infinite number of numbers that are bigger than or equal to 9. Okay, that's what I was talking about when I mean infinitely many solutions. So what I'm going to do is I'm going to take each of those 4 numbers and plug them in for n. So is 6 bigger than 9? It is not, so it's not a solution. Is 13 bigger than 9? Yes, it is. So 13 is a solution. Is negative 25 bigger than 9? No, it is not. And the last one is 9 bigger than or equal to 9. So is 9 greater than or equal to 9? Well, it's equal to, so yes, it is a solution. Okay. Now, real quick, true or false? Is this inequality has 2 solutions? Hopefully a question popped up on your screen, and you should have answered false. Of the 4 listed, only 2 of them were solutions, but this inequality has infinitely many solutions, like I've already said. Okay, number 2. I'm going to take 2 and put it in for h, and it gets a little more tricky when the variable's on the right-hand side. So 6 is greater than 2. Is that a true statement? Is 6 bigger than 2? Yes, it is. Negative 18. Is 6 bigger than negative 18? Yes, it is. Is 6 bigger than 15? No, it's not. Is 6 bigger than 6? No, it's equal to. Therefore, it's not a solution. The last one, much trickier because the first two were already set up with the variable by itself. This time, I've got an exponent and I've got some other things going on. Okay, I'm going to take the numbers and plug them in. -9, I'm going to plug it in. Make sure, remember, when you're evaluating, when you're plugging a number in for a variable, use parentheses, because -9 squared, if you don't use the parentheses, it'll tell you it's -81, but -9 squared is +81. And 81 plus 3 is 84. Is that a true statement or a false statement? Well, 84 is definitely not less than 28, so no, it's not. Now let's do 3. 3 squared is 9. 9 plus 3 is 12. Is 12 less than or equal to 28? Yes, it is. How about -5? -5 squared is 25. Plus 3 is 28. Is 28 less than or equal to 28? It's equal to, so yes, it actually does work here. Last one is 6, so 6 squared plus 3, is that less than or equal to 28? 6 squared is 36, plus 3 is 39. Is 39 less than or equal to 28? It is not. Okay, so that's how you check to see if a number is a solution to an inequality. All right, let's go to the back. Since inequalities have infinitely many solutions, it is impossible to list them all out. We need a way to show all of these solutions. The only way to do this is to use a graph. You have to shade one side of the number line to represent all the solutions. All right, so show all the solutions to the inequality. So x is greater than 7. So I'm going to draw a number line. I'm going to put 0 in the middle. I'm going to put 7, which is on the right-hand side of 0, because it's positive. Okay. I want to shade x, basically. What numbers are going to make that a true statement? So x could equal 8, 9, 10, 11, and so on, right? Could it equal 7? No, it can't, because it's not equal to 7. So what we do is we put a circle there, and then I'm going to shade all of those numbers. So I'm going to shade it like this, or draw an arrow to the right, and that's representing all the solutions. We'll do the next one. M is less than or equal to 1. Again, 1 is positive, so I'm going to put it to the right. I'm going to put a circle at 1. What numbers are going to make that true? What numbers could I put in for M to make that true? Well, 0, -1, and actually 1 would work because it's equal to. So 1, 0, -1, -2. All those numbers are to the left of that circle, but I have to include 1. The way that we show that we include 1, whereas in the first example over here, we did not include the 7. In this one, we do include the 1. To show that, I'm going to color in that circle. Big point there. And then I'm going to shade all the numbers to the left this time. And that represents all the solutions to that inequality. Now, a couple differences. I've already pointed them out, but I'm going to put it in writing now. When do you use an open circle like we did with number 1? Well, you use an open circle when you have this symbol or this symbol. So greater than, less than. When do you use a closed circle? When you have equal to. Make sure you make that distinction. Okay. Now, some of you may have learned this in prior math classes, and somebody may have shown you a shortcut with shading. Please, please, please don't use that shortcut. Think about what you're doing. Kind of like I reasoned through what I did here and what I did here. Think through it. I don't need you to write it down, but think through it. That's going to prevent you from making silly mistakes. Let me show you what I'm talking about. Show all solutions to each inequality. If you follow the shortcuts, this first one you would probably get right. Okay. Start with a number line, 0 in the middle, -4 is to the left. So -4 is over here. It's an open circle because it's a less than. And you'd think, oh, it's pointing to the left, so I'm going to shade to the left. That's the shortcut a lot of people learn. In this case, it works. Okay, let's look at the next one, number 2. 0, 82 is a positive number to the right. It's equal to, so it's shaded in. If you follow the shortcut that I just said, that you might have learned in middle school, you're going to shade this one to the right. Okay, you're going to go that way with it. But let's think about this. Find numbers that make this true. 82 is bigger than what? Well, 82 is bigger than 81. It's bigger than 80. Well, where are those numbers? Those numbers are to the left, right? So I'm actually shading this one this way, which can throw people for loops a lot. That's why I'm telling you to think about it. What numbers make this work? And then shade that way. Okay. Another thing you can do is you could switch it and put the variable on the left and put the 82 on the right. But what you have to remember to do there is switch the sign around. The alligator's eating the 82. It's got to continue to eat the 82. Okay. And yet another way of doing it is to take a test point. And I'll show you that method with the last one. So test point. I'm going to pick a number that is not -5. Not going to choose -5. So I'm just going to choose 0. Okay. We'll go ahead and set up my number line. 0 in the middle, -5 is to the left. I know it's an open circle because it's less than. Okay. 0. I'm going to put 0 in for H. If it's true, I'm going to shade towards 0. If it's false, I'm going to shade away from 0. So let's try it. -5 is less than 0. Is that true? Yes, it is. -5 is less than 0. So I'm going to shade towards 0. Okay. So I've shown you 3 ways to the graph. Shortcut, that was number 1. Don't like that one. Number 2, think about numbers that work and shade that way. Or number 3, pick one point. If it's true, shade that way. If it's false, shade the other way. And I'll do one more that's not on the notes here to show you what it would look like if I do a test point that's false. So let's say I've got 10 is less than or equal to M. And I'm going to graph that. Here's 10. I'm going to choose my, or it's closed circle. I'm going to choose my test point of 0 again. So I'm going to put 0 in. Is 10 less than 0? No, it's not. So I don't want to shade towards 0. I want to shade away from 0. Okay. All right, let's move on. And we're going to actually now write inequalities from words and from graphs. So to do well on a test, you should spend at least 45 minutes studying. So we're going to write an inequality from that because we have the word at least, which means it doesn't have to be exactly 45. It could be 45 or something else. But I'm going to write a variable first. The thing that's changing is how many minutes. So I'm going to do M standing for number of minutes. So what are some numbers that would work? Well, 45 would work. What else? At least 45. So that's the least it could be. So I want numbers bigger than 45. 46, 47, right? So I'm going to write my inequality M 45. I want the minutes to be bigger than or equal to 45. And I include equal to because 45 did work. So you kind of have to think through that. You're going to get to practice that more. Number 2 is another example of the same idea. The car can go at most 120 miles per hour. So I'm going to let, we'll just call it speed. We'll just call X, say speed. Well, the first part is pretty easy. X and 120, we're going to compare those. Well, what are some speeds that the car can go? Well, it can go at most 120. So that's 120 is what it can go. So it can equal 120. So I'm going to go ahead and put the equal sign in there. What are some other speeds the car can go? Well, it could go 10 miles an hour. It could go 50 miles an hour. So it's numbers less than 120. Okay, if you don't think about it, you see the words least and think less than, most and think greater than. Stop and think about it. It's actually not the way it works. From the graph is a little bit easier, at least in my opinion. I always like to put the variable on the left. You don't have to. And the number that has the circle is -1. Is it filled in? Yes, it is. So it's going to be equal to. And it's shading to the left. So it's shading the numbers less than -1. There you go. And then the last one, I do, again, x. It's at -3. It's open, so it's not equal to. And its numbers bigger than -3. And that's our introduction to inequalities. We're going to look at some more advanced inequalities in the next lesson, and we're going to start to solve those.